welcome everyone. Before we start, I'd like to mention that it's a friendly and inclusive space where we promote a warm and respectful environment for everyone. Let's encourage each other and lift one another up. Please be focused on learning and sharing knowledge. Please maintain a professional and friendly attitude. We aim to create a safe, friendly atmosphere for all participants. Harassment or disruptive behavior won't be tolerated. This is a space for tech lovers. So let's stay focused on learning, sharing, and collaborating on technical topics. We love a balanced community. So share your ideas, listen, and contribute in any way that feels right. If something doesn't feel right, let the host know during the event or reach out via email. We are here to make sure everyone feels comfortable and included. Excited to have you here for Machine Learning Study Jams. This is a community-driven program designed to help beginners get started with machine learning. Whether you are completely new or looking to reinforce your understanding, you are in the right place. Let's learn and grow together. Machine Learning Study Jam is a collaborative learning program that helps community members develop as machine learning practitioners. The idea is to review the core concepts of machine learning and share knowledge within the community. This week is all about setting the foundation. We'll introduce machine learning, go over key concepts, and give you a roadmap for self-paced learning. Our main resource is Kaggle's Intro to Machine Learning course, which you can complete at your own pace. No coding experience? No problem. Intro to Coding Program course. This course is for you. If you have never written a single line of code and you are interested in learning data science and machine learning, so you can start from Intro to Programming. It's free course on Kaggle. Everyone who finished a Kaggle Learn will receive a competition certificate, which you can find by navigating to the Learn page. And of course, you can share your certificates on LinkedIn, Facebook, everywhere you want. Okay, let's take a look at what's ahead in our machine learning study jam journey. First 4 weeks is required, last 5 optional, which will be full of workshops, presentations from interesting speakers. Okay, let's talk about our first week. This week, Intro to Machine Learning and Pandas. We start with the fundamentals, understanding what machine learning is and how it works. We also explore Pandas, which is a key Python library for handling and analyzing data. Next week, 2, Intermediate Machine Learning and Feature Engineering. We'll go deeper into feature engineering, a crucial step in machine learning where we transform raw data into meaningful inputs that improve model performance. At third week, which is Intro to Deep Learning and Computer Vision, we'll explore deep learning, the technology behind artificial intelligence breakthroughs in speech and image recognition. We'll also introduce computer vision, which allows machines to see and process visual information. By the way, next week, 15th of February, we'll have online 2-hour workshop, which is part of Build with AI series of events, revolutionizing gaming with computer vision with our amazing speaker, Shrikanta, He will dive deeper and share his experience uh, about how he updated and used classic Snake game using computer vision. So feel free to register on our Google Developer Group Ahlen official webpage. At fourth week, which is time series and intro to AI ethics, we'll focus on time series forecasting, a key techniques for predicting future trends in fields like finance, healthcare, sales. We'll also discuss AI ethics, ensuring we develop responsible and fair AI solutions. After completing the first 4 weeks, you will have a strong foundation in machine learning, deep learning, and time series forecasting. For those who want to go further and explore cutting edge AI technologies, we are offering an optional advanced series covering generative AI, embeddings, and MLOps for AI development. So, let's talk a little about these five series. At week number 5, which is foundational models and prompt engineering, we'll explore large language models and how they work. You'll learn how to effectively design prompts to get the best results from models like Gemini, GPT, and other foundational AI systems. At 6th week, embedding and vector stores data sets, we focus on vector embedding, which are key to search engines, recommendation system, and AI memory. We'll also introduce a vector database like FACE and Pinecone for efficient AI-powered retrieval. At 7th week, generative AI agents, which is my loveliest topic. This week, we move beyond single AI models and explore multi-agent AI system, where LLMs work together autonomously to solve complex tasks. We'll cover AI agent frameworks and how they can improve automation. At 8th week, domain-specific LLMs, we will talk about AI models because not all AI models are one size fit all. In this session, we'll learn how to fine tune and customize LLMs for specific industries like healthcare, finance, law to make them more effective. And on our last week, which is MLOps for generative AI, we'll wrap up with MLOps, which focuses on deploying and maintaining AI models in production. You'll learn best practices for scaling, monitoring, and optimizing AI applications to ensure they run efficiently. These 5 weeks are a great opportunity to gain hands on experience with advanced AI techniques and apply them to real world forecasting and automation tasks. Whether you are looking to specialize in generative AI or enhance your machine learning career, this series I hope will prepare you for the next level. And of course, let's talk a little about organizing this machine learning strategy. Every Sunday, we'll have short online events with introduction necessary materials for the next week. Also, you can communicate on our new Discord channel. The link I'll share with later. Every week, I'll introduce homework. It's a list of required courses which you need to finish during the next week and before the next online session. Today, we're starting from the very basics, so no prior experience is required. This session is completely beginner friendly. First, we'll cover some key machine learning concepts, what machine learning is. Then we'll walk throughout a step-by-step guide to Kaggle Intro to Machine Learning course. This session is all about getting hands-on exploring machine learning fundamentals. Machine learning, what it is? It's powers some of the most important technologies we use, from translation apps to autonomous vehicles. This course explains the core concepts behind machine learning. Machine learning offers a new way to solve problems, answer complex questions, and create new content. Machine learning can predict the weather, estimate travel times, recommend song, autocomplete sentence, summarize articles, and generative never seen before images. In basic terms, machine learning is the process of training a piece of software, which called a model, to make useful predictions or generate content from data. For example, suppose we wanted to create an app to predict rainfall. We could use either a traditional approach or a machine learning approach. Using a traditional approach, we'd create a physics-based representation of the Earth's atmosphere and surface, computing massive amounts of fluid dynamics equations. This is incredibly difficult, but using a machine learning approach, we would give a machine learning model enormous amount of weather data until the machine learning model eventually learned the mathematical relationship between weather patterns that produce differing amounts of rain. We would then give the model the current weather data and it would predict the amount of rain. I'd like to share with you this short 2 minutes video about what machine learning is, so I'll share it in chat and later duplicate. When we talk about machine learning systems, we categorize them based on how they learn from data and what kind of tasks they perform. Supervised learning, unsupervised learning, reinforcement learning, and generative AI. Let's talk a little about these systems. Supervised learning, this is the most common type of machine learning. Here, the model learns from labeled data, meaning we provide both the input and the correct output. It finds patterns and makes predictions like spam detection in emails or image classification. Unsupervised leading, in this case, the model works with unlabeled data and finds hidden patterns or structures on its own. This is commonly used in clustering, like customer segmentation and anomaly detection, like fraud detection in banking. Reinforcement learning. This is used when an artificial intelligence model learns by interacting with an environment and receiving rewards or penalties for its actions. It's how AlphaGo defeated human champions and how robots learn to navigate physical spaces. Generative AI, a more recent and powerful category. It focuses on creating new content, whether it's text, images, music, or even code. LLMs like Gemini or ChatGPT and generation models like Stable Diffusion and DALL-E are examples of this. Each of these machine learning types plays a crucial role in building intelligent applications, and throughout this series, we'll explore how they work in real world use cases. So, supervised learning models can make predictions after seeing lots of data with the correct answers and then discovering the connections between the elements in the data that produce the correct answers. This is like a student learning new material by studying old exams that contain both questions and answers. Once the student has trained on enough old exams, the student is well prepared to take a new exam. These machine learning systems are supervised in the sense that a human gives the machine learning system data with the known correct results. Two of the most common use cases for supervised learning are regression and classification. Let's talk a little about regression classification. A regression model predicts a numeric value. For example, a weather model that predicts the amount of rain in inches or millimeters is a regression model. Classification model predicts the likelihood that something belongs to a category. Unlike regression models whose output is a number, classification models output a value that states whether or not something belongs to a particular category. For example, classification models are used to predict if an email is spam or if a photo contains a cat. Classification models are divided into two groups: binary classification and multi-class classification. Binary classification models output a value from a class that contains only two values. For example, a model that outputs either rain or not. Multi-class classification model outputs a value from a class that contains more than two values. For example, a model that can output either rain, hail, snow, or sleet. Watch this short video with great supervised machine learning explanation. It's less than 2 minutes, so let's share now a chat. And later I'll of course duplicate this link on our Discord channel and on email. So let's take a look at unsupervised learning models. Make predictions by being given data that doesn't contain any correct answers. An unsupervised learning model's goal is to identify meaningful patterns among the data. In other words, the model has no hints on how to categorize each piece of data, but instead it must infer its own rules. A commonly used unsupervised learning model employs a technique called clustering. The model finds data points that demarcate natural groupings. Clustering differs from classification because the categories aren't defined by you. For example, an unsupervised model might cluster a weather data set based on temperature, revealing segmentations that define the seasons. You might then attempt to name those clusters based on your understanding of the dataset. Now let's talk about reinforcement learning, one of the most fascinating areas of machine learning. Unlike supervised learning, where models learn from labeled data, reinforcement learning models learn by trial and errors, similar to how we learn new skills. How does it work? The model interacts with an environment and takes actions. It receives rewards for good actions and penalties for bad ones. Over time, it learns a policy, a strategy to maximize rewards and make the best decisions. Real world applications of reinforcement learning, for example, robotics. Teaching robots how to walk, navigate rooms, or pick up objects. In gaming, amazing example is AlphaGo. The AI system that defeated world champions in Go learned by playing millions of games against itself. Or, as an example, self driving cars. Reinforcement learning helps vehicles learn how to drive safety by simulating different driving scenarios. Reinforcement learning is especially useful when outcomes depend on long term strategy rather than just immediate results. It's a key part of AI's progress toward autonomous decision making. Let's dive deeper into one of the most exciting areas of AI today, generative AI. Unlike traditional machine learning models that focus on classification or prediction, generative AI creates new content based on user input. It can generate text, images, music, video, code. And how does it work? Generative AI models learn patterns from massive data sets and use that knowledge to create original content. Think of it like a comedian who learns to mimic different speaking styles, an artist who studies painting to recreate a similar style, or a cover band that replicate a famous musician's sound. Initially, these models are trained using unsupervised learning, where they analyze large amounts of data to understand patterns. Then they might be further refined using supervised learning or reinforcement learning to improve performance on specific tasks, such as summarizing articles or editing photos. For example, real world applications such as enhancing e-commerce, improving product images by removing backgrounds or enhancing resolution, in content creation, generating blog posts, music, and even video scripts. In marketing and design, automating advertise creatives and personalized content generation. So, generative AI is evolving rapidly, expanding possibilities in creativity, automation, and problem solving. It's transforming industries and opening up new ways to interact with technology. To make the most of our next session, we have some essential homework for you. Over the next week, please complete two Kaggle courses. Intro to Machine Learning. I'll share the link in chat. And when you open this course, you'll understand that it has just 7 lessons. It's short lessons. So this course will introduce you to core machine learning concepts and help you build your first models. When you finish lesson, at the top will be our start tutorial, which switch you to the next lesson, or to start exercise, which is necessary to finish if you want to get certificate. So you'll learn about training data, validation, and key techniques like decision trees finishing this course. No prior experience is required. It's great hands-on introduction to machine learning. And pandas. This course focused on data manipulation, a crucial skill for working with data sets in machine learning. You'll practice loading, filtering, and transforming data using pandas, one of the most powerful Python libraries for data science. Why is this important? Both courses provide fundamental skills that will help you understand and apply machine learning concepts in future sessions. Completing them will ensure you are ready for the next steps in our learning journey. Where to find them? Both courses are available for free on Kaggle. If you haven't already, create a Kaggle account and start working. So it's time, please create. It's totally free. All links I'll share with you. So next steps. Set aside time this week to complete both courses. Take notes and try running the provided code examples. If you have any questions, bring them to our Discord channel. We'll discuss and clarify them together. Also, I'd like to share with you amazing resource. The foundational courses cover machine learning fundamentals and core concepts. So we recommend taking them in the order below. So the link now I'll share in chat, and you can start Introduction to Machine Learning, and you can finish this course, and Machine Learning Crash Course, which contain more than 100 exercises, 12 models. It will take 15 hours, but here collection of amazing material. And this is very informative, just 7-minute video, Intro to Machine Learning. I'll share with you link in chat also. So just 7 minutes and you will dive deeper into Intro to Machine Learning. And CodeLab from Google, say hello to the hello world of machine learning. Amazing CodeLab. So you can open, and here just 5 short models. So you can quickly finish and better understand what machine learning is. And at the end, congratulations. So that brings us to the end of today's session. Thank you all for your participation. Remember to complete your homework on Kaggle, both the Intro to Machine Learning and Pandas courses. If you have any questions, feel free to reach out in our community Discord channel. This session was recorded and will be available on our Google Developer Group Ahlen YouTube channel later. You can rewatch it at your convenience. I'll also send an email with the recording link, all resources and links mentioned today, additional learning materials. Please don't forget to submit the post-event feedback form. Your insights helps us improve and make future sessions even better. Once again, thank you for joining. We look forward to seeing you in our next session next Sunday. Until then, keep learning, experimenting, and building with